Okay, so this is chapter 6.5, right where we left off. So we're on example 4. First thing you want to do is square both sides of the equation. So I square both sides. This one's going to become t plus 5 times t plus 5. Remember, when you square a binomial, you have to make sure you actually end up foiling it. And this one, the square root goes away because a square undoes a square root. So now you have to actually multiply this stuff through. So I have t squared plus 5t plus 5t plus 25 is equal to t plus 7. Combine your like terms. So I have 10t here plus 25 equals t plus 7. Because I have this t squared, that means I'm going to have to end up factoring. So in order to factor, you have to have 0 on one side of the equation. So to do that, I'm going to have to subtract off this t and subtract off this 7. So I'm going to have t squared plus 9t plus 18 is equal to 0. And now I have to factor. It's a quadratic, so I'm looking for numbers that add to positive 9 and multiply to positive 18. We can start by putting our t's here. So if it has to add to 9 and multiply to 18, it's multiplying to a positive. That means I have to have the same sign. And since I'm multiplying to a positive number, that means, or adding to a positive number, that means that both of the signs have to be plus. And the numbers that would work would be 3 and 6. So then from here, set each piece equal to 0. And now solve for t. So you would have t equals negative 3 and t equals negative 6. After you subtract 3 from both sides, subtract 6 from both sides. So from here, remember, because there's a square root and because we ended up squaring, we could have added in an extra solution. So what you need to do is you need to check your answers. So that'll be the next step. So when I do the check, I have my first solution I said is t equals negative 3, so let's check that one. So let's check t equals negative 3. So plug in negative 3 into the original equation. And I want to make sure the left-hand side equals the right-hand side. So on the left-hand side, I'm going to have 2. On the right-hand side, I have the square root of 4, which the square root of 4 ends up giving me 2, so it checks. So then I need to check, so I know that t equals negative 3 is a solution. So now I need to check t equals negative 6. So plug in your negative 6. So negative 6 plus 5 equals square root, plug in negative 6 on the right hand side, and simplify. So negative 6 plus 5 is going to give me negative 1. Over on the right hand side, I'm going to have the square root of 1, and negative 1 does not equal the square root of 1 because the square root of 1 is just equal to 1. So that means negative 6 is not a solution, and t equals negative 3 is the solution. So that's example 4. Example 5, we have the same idea, and like we did on the previous problem, we tried to get the radicals on one side of the equation and everything else on the other. In this case, I have a radical on both sides, and I can't really move that negative 3 right now. There's no, I mean, I can move it to the other side, but it's not going to help me in any way. So I'm just going to square both sides as is. So I'm going to have this squared and this side squared. So remember that this would become x minus 3 all squared, and the other side, I'm just kind of rewriting it here because it looks kind of messy, is going to be the square root of x minus 3 times the square root of x minus 3. So this side over here is just going to become x minus 3 because squaring a square root undoes itself. And over here, you're going to have to actually FOIL. So if I multiply the square root of x by the square root of x, that's going to end up being the square root of x squared. When you take the square root of x squared, it's just going to be x. Or the shortcut is just know that if you have the same thing under a square root and you multiply them together, you're going to be left with what's under the square root. So regardless, I'm left with x. Then you're going to have minus 3 times the square root of x, so I'm foiling through. So now I have to do these pieces, so minus 3 square root of x, and then lastly I have plus 9 when I multiply negative 3 times negative 3. So now I have x minus 3 equal to x, combine your like terms. And remember, when you're subtracting or adding radicals, you kind of want to think of it as it's got to be a like radical in order to subtract or add. So I can combine these, keeping the radical x and subtracting the exponents, or subtracting the coefficients. So I'm going to have minus 6 square root of x plus 9. And then from there, you want to figure out what x is. So get x by itself. So start combining some like terms. So I have an x and an x. So let's move that over. I can also bring this 9 over. So my x's are going to cancel here. This is going to be a minus 12. And then I'm going to have a negative 6 radical x. Those are gone over there. And now it's up to you. At this point, you have to try to figure out x. So whenever you have a square root of x, to get rid of the square root, you square both sides. So before doing that, if you want, what you can do is get the square root, isolate the square root. And in this case, I can isolate the square root by dividing both sides by negative 6. It's not a big deal to just square both sides as is. It's just you're going to be dealing with bigger numbers. You're going to end up with 144 and 36. So, I mean, it's not a big deal, but it's probably easier just to divide over that negative 6 right away. So divide over the negative 6, I get 2 equals the square root of x. Now I want to square root or square both sides. So I have 4 equals x. So we don't know if that's the answer yet. We have to make sure we check it. So once I do my check, we plug in 4 into the original. So I have 1, the square root of 1 over here, 2 minus 3. I get 1 equals negative 1, which is not true. So this is not a solution, which means that I have no solution. And then for the next one, it's kind of the same concept. I mean, it's very similar format if you compare example 5 with example 6. Format's not really anything different, but I'll go through it anyways. When I see this one, again, you can't really isolate the radical because these are not like radicals, so there's no way for you to combine those. Moving this one over isn't really going to help you, so you can just square it as is. This part here is just going to become x plus 1 because you're squaring a square root. And this side, you want to make sure that you end up foiling because you're multiplying a binomial times a binomial. You don't want to just think of it as distributing the square through each term because it has a minus, so whenever it's a minus or a plus, you have to make sure that you multiply through using the FOIL method, or thinking it as distributing the 1 through to each piece and then the radical 2x through to each piece. So that'll be my next step, is to actually FOIL that stuff out or multiply the binomial times binomial. So I have 1 times 1 gives me 1. 1 times negative radical 2x gives me negative radical 2x. Then I have this minus radical 2x, and then plus radical 2x times radical 2x is just going to end up giving me 2x. Make sure you put the plus because it was a negative times a negative. Now again, remember, if you don't like doing the shortcut, if you multiply these, radical 2x times radical 2x gives me the square root of the entire 2x squared, which when you cancel it, when you take the square root of something squared, you get what's under it, which is 2x. So you can write it all out or you can do the shortcut. So then combine your like terms. So this is a minus 1 in front of these. So this ends up being 1 minus 2 radical 2x plus 2x. And then from there, you want to solve for x. So let's get our x's together. Let's get our numbers together. Let's group some like terms here. So subtract the 1 from both sides. That's going to cancel. We can move this 2x over. So those are gone. So this is going to end up giving me negative x equals negative 2 radical 2x. And then at this stage, again, like the last one, if you want to divide over that negative 2, you can. I'm going to recommend this time that we don't, only because if I divide over that negative 2, I'm going to end up with a fraction on the left-hand side. And usually we don't like to deal with fractions. You can, but typically we don't like it. So instead, I'm going to now square both sides at this step because I got to get rid of that radical. So when you square negative x, it's just going to become x squared. Now you want to think of distributing this squared through, or squaring each individual piece. And the reason why you can do it here and not up top here is because now these are multiplication, the operation between them, where up here was a minus. So I'm going to square each piece. So squaring negative 2 is going to give me 4. Squaring this is going to give me just what's underneath the radical. Remember, the operation's multiplication. So now you end up with an x squared. Whenever you have an x squared, you do not want to divide by x. You want to think factor, get 0 on one side of the equation. So before I get 0 on one side of the equation, let's just rewrite this as x squared equals 8x. Multiply that 4 and 2. And again, don't divide by x. You can't do that. That'll get rid of a solution. So what you need to do is you need to factor. So in order to factor, we're going to move that 8x over to the other side. So I'm going to subtract 8x from both sides. And when I do that, I'm going to have x squared minus 8x equals 0. And then from here, remember when you factor, you always want to try to pull out a greatest common factor if you can. In this case, I can pull out an x. Then I would be left with x minus 8, which equals 0. Now you have two things being multiplied to equal 0, so you can set each piece equal to 0. So here's one answer. Now add 8 to both sides, you get x equal to 8. And then you would do the check, and when you actually do the check, you're going to find, so I'm just going to write, do the check. When you do the check, you're going to find that x equals 0 works, and x equals 8 does not work. So this one doesn't check. And that would be it for this section.